Okay, here's the setup for the 1903 Falcon digital. Little background, my buddy had a 63 convertible that we put a T5 transmission in. Well, on that transmission there wasn't any provision for speedometer. So I volunteered to come up with a GPS-based speedometer system for him. And I must say I probably got a little bit carried away. Now, to give you some idea of what all's going on, in that little red box there is the GPS sensor. That'll be routed around and put up on the dash near where the radio speaker would be. This USB cable that comes out of the unit is used to attach a computer to it for testing and debug. This is a little mock-up panel that I put for demonstrating and testing. We have the equivalent of an ignition switch. We have a headlight switch. Then we have a rheostat for the speed, the fuel, the oil, and the temperature. When this is installed in the car, the speed will be determined by the GPS signal out of this box. The fuel uses a standard Falcon fuel sender, and a little bit more on that later, shortly. The oil pressure, I used a precision 0 to 100 psi 3-wire oil sender, and the temperature signal will be tapped from his computer system temperature sensor. He also has put a 91 Mustang 5.0 electronic fuel injection engine in his car, which is why we're going to use the same temperature sender, just tap the signal off of it for that the computer uses. Now, to get the look of the unit to match stock, I put everything into the original can and display bezels, so forth. You'll see that the speedometer is actually going to be a bar graph that runs 0 to 80. And I'm going to turn the unit on now to start demonstrating some of this. There we go. Now, we've got the speedometer, as I said, will go from 0 to 80. I'm using the rheostat now to fake a speed signal. And if you notice, I put a digital readout embedded into the bezel right above the Falcon logo. Now, right now it's reading the speed of 29 miles an hour, and there it is on the bar graph. If you notice that as the speed increases, the lower segments of the bar graph will go a little dimmer, so as to pull your eyes to the right end of the bar graph, which is a little bit brighter. So as we go up, eventually we'll hit, and see how it's getting brighter and brighter. Like I said, it only goes down to 80, 81 miles an hour, 82. Once you get over that, it begins to flash saying you're going too fast. So there's two reasons for that. One is you shouldn't be taking a Falcon any faster than 80 miles an hour without a warning. And then the second reason was that in order to conserve the amount of output chips required to run the bar graph, 88 is basically a binary computer number. Anyhow, we'll move along. Now over here we have the fuel. Now what I did here was we're using the standard fuel gauge. As you can see in the bottom right below the U, we've got the little needle there. It's a standard fuel gauge. Now I put a rheostat to send the signal to the fuel gauge, and I've increased it slightly now, and you can see that the fuel is inching its way up. There's time delay built into the display in order to simulate the speed of how fast the needle tracks. But you can see right now we're at 10 gallons basically. Anyway, that's what the readout says. And the needle has moved its way up toward the 10-gallon mark. Basically, I set the digital readout to read when it's full 16 gallons, because he had a 16, let's see, 4, 8, 12, 16-gallon tank. And so at 3/4 would be 12, and at half full would be 8, quarter full would be 4, and so forth. So it's still a stock fuel gauge with a digital meter attached to it. Here we have an oil pressure gauge, which, as I said before, is we use a precision oil pressure sender to get the signal in. And one of the features of this oil pressure gauge is when we lower it down using the rheostat below 20 psi, then we start getting a blinking low readout on the oil pressure gauge to let us know that we've got low oil pressure. Now at this point we don't really know what the oil pressure is, but it doesn't really matter. If it's below 20, it's too low. So I wanted to catch the driver's attention to the possibility of blowing up an engine if the oil was too low. Right now I have the buzzer disconnected that would also give you a warning so that it doesn't interfere with my narration. Next to that we have the digital readout that is used for both the readout of the speed and the odometer, but it also has other functions as well. There are some switches located beneath the unit. There they are. From left to right we have blue, white, yellow, and black. Now the blue is for selecting the odometer, which is the default how it would start up. The white, and next to it will change the okay. The white next to it will change the readout from the odometer to the trip odometer. You can see we've got 19.7 miles that we've been playing around with. Now, bar graph still is going to read the speed. It still shows the speed in miles per hour. Now, next one over, which is the yellow, will do two things. One, it will reset the trip, and it will take you back to the odometer. So to see that we did reset the trip, I'll push the white one. There you go. And we're back to there. So you have a trip odometer as well as a engine odometer. Now, I can preset this odometer to whatever my buddy would like me to put in there. If it's 0, then 0, which is what I'd recommend, because it would tell him how many miles is on his new engine and drivetrain, new transmission, so forth. And then here we have a voltmeter. It's just a straight voltmeter, and it doesn't tie into the system at all. So there's no warning or anything like that involved. It's just to let the driver know whether his alternator is charging or not. Over here we have a temperature readout, and we're using the sensor off of the Mustang temperature sender that it sends the temperature in for the computer. And I've got it calibrated from low temperature, about 150 degrees or so, and it goes up from there. Now, I've got it blinking because eventually, as this settles out, we will be in an over temp situation. Again, it's blinking. Now, this will show the actual temperature, because it would be important once you get above, I think I set the set point at like 220 degrees or something like that. Once you get above 220 degrees, 220 degrees, then it'll be important to know what the actual temperature is that we've gotten to. In any case, you can see the little needle is also tracking the temperature, so we get a stock look, to it. Now, the needle on this gauge is actually just tracking what the temperature sensor from the engine computer tells us. So it's not directly, the gauge, this temperature gauge is not directly connected to a temperature sender on the engine like the oil pressure unit is. And it was just done to make the needle do something for a stock look. Now the last button, the black button on the far right, I haven't covered what it does. And what it does is it converts the bar graph display to a tachometer. Now it says it'll still give you the mile per hour reading, so if you're going down the road, you still know how fast you're going. And we can simulate the speed, get it up to 60 mile an hour or so. Okay, and now the reason that we're getting all kinds of blinks going on is the tachometer signal is not hooked up, so it's just getting spurious noise. Normally, when it's hooked up to the tach wire from the computer harness, then we would be getting a signal and it would track the engine speed. Now pushing that black button again will switch us back to the odometer, and you can see we're sitting there at 62 miles an hour. I'm going to turn the lights off, and you can see that how the display looks, how the cluster looks with the lid up. So it's quite attractive. And there's a speedometer coming up. But as you can tell, the display is pretty bright at night. So what I've done is we've run the wire for the headlights, or the dash lights in to the unit, and when you turn the light switch on, it will dim down the bar graph. I don't know if it makes a lot of difference, but here we'll try it. Just having a hard time focusing in this darkness. There's with the lights on, and there's with the lights off. And the thought here is that at night you don't need that quite so bright. Also, I was able to put a alarm in the unit to where when you turn ignition off, if your headlights are still on, or your parking lights, it will sound the buzzer until you turn the headlights off or turn ignition back on. Now I've opened up the unit to show you what's inside, and you can see over to the left is our fuel gauge, and over to the right is our temperature gauge, and there are the 4 switches we talked about earlier. And this unit is the brain of the system. It uses an Arduino Mega board. It's a microcomputer board. Okay, on the back side of the unit, you can see here's the wiring for the display. Most of it are like these chips here. Each one of those chips will run a number of segments, and all along here, all of these wires then come from those chips, go down to the actual bar graph, which is that long line of terminals there. And then this is one of the gauges readouts. Can't really see it, but behind all of those wires right there is the digital display on the front. And here's another there's the voltmeter. And then we have the temperature digital readout display board over here. This is a power board, and over here is a power distribution board. And these chips here are for the oil pressure readout. So that's pretty much it. Everything's been tied down and soldered together, hopefully to keep it from coming apart once he starts driving it.